right, everyone, welcome back from break. Our next session will be in the infrastructure and superstructure track. It's called Vulnerabilities and Misconfigurations in GitHub Actions by Rojan Rijal. It's sponsored by Permiso. And Permiso is a cloud detection and response company that creates session constructs for the identities across cloud and SaaS applications to break down visibility boundaries and understand user behavior and intent across your environment. Just a few quick reminders. So in the Slack channel, pinned in the forward CloudSec channel, there is a question in regard to who's going to do game day challenges. So if you could thumbs up that if you plan to participate, that would be great. And then after our sessions, please take advantage of the speaker booths down the hall. Over to you.
Awesome, thank you. Hello, everyone. My name is Rojan. So this talk is focused on GitHub Actions, vulnerabilities, and misconfigurations. It is a 20-minute talk, so it's going to be pretty lightning, not fully in depth. We're just going to summarize some of the stuff we have seen, and then just go over there with some of the vulnerability and how to patch them as we go as well. Now, if you're not fully aware of how GitHub Actions work, it is pretty much like a CI/CD pipeline as a service that GitHub provides. It is in YAML template language format and runs as event-driven triggers, which is basically the idea that it will only execute on certain situations. Common cases, if you're as a company trying to use GitHub Actions or if you have already used it, it's going to focus on things like PR validations when someone has opened a pull request, running some integrations test on it before you are able to merge it to a main branch. You can also do things like automated deployments to your infrastructure, whether it's in AWS or creating Docker images if you're creating an open source binary. If you have used like popular recon tools or security tools from Project Discovery, majority of their toolings work from GitHub Actions and auto-deploy to their Docker images whenever it's ready on the main branch. There's also security side of it. You can use it to run some basic security scanner tools. There's also GitHub's code security scanning that is also supported via GitHub Actions, so you can also use it there. But that said, a sample workflow, since it's in YAML, can be defined in this kind of a way. So there's three specific things when we look at a GitHub action workflow. The first, as I said before, is the event that triggered the action. In this case, it will only trigger when there's a push request to the master branch and then when there's a pull request. For the pull request side, it will work on any section of pull request, whether it's opened, reopened, synchronized, labeled, all of that. And then you can add additional validation when it moves to the jobs section. You can have multiple jobs in a workflow. So a job 1 could be running in the same time as job 2. Since they're parallel, you can link them together. For example, job 3 to validate things in job 1 and 2 before it actually goes through. And then within job 1, you can have steps. So here we have 3 different steps. The first one checks out the repo. Second one uses a third party, aka my action on Tinder Rojan/build test. And then it will run a local Python script to go through and run its own command, passing in a secret variable to it with the secrets.ssh and github.token. Github.token is pre-configured, so it comes with every workflow. It used to have read-write access. Now it only has read access. We'll see more into why that happened a lot. It's mainly through a lot of vulnerabilities that came out with people misconfiguring their GitHub Actions there. Now, when we look at event triggers, I usually like to call some triggers user-controlled, even though there are other triggers like push and workflow dispatch, which is technically user-controlled because the user is requesting the workflow to run. In our case, when we say user-controlled, it's more of the event has additional inputs that a user could provide. So for example, with issue and issue comment, it will run every time an issue is opened, updated, edited. With issue comment, it will run every time there's a comment on an issue. And then you have pull request and pull request target, which can run whenever a pull request is opened. There is a slight difference between pull request and pull request target that actually makes a major difference security-wise. We'll see it in the vulnerability example. So for example, the first vulnerability we're going to cover is pretty standard. GitHub has written a blog on it, so GitHub already has something out for that. There's numerous blogs, and it is the standard command execution when you write a workflow. Since workflow is taking a user input, there can be cases where you can have an RCE. So in this workflow, we have 4 different steps that run when an issue comment has been made. In this case, at any comment on an issue, it will run, and then it will initially do a if check to make sure it's a comment in a pull request. And we'll see a first line of vulnerability there where it does a starts with. So it's checking that the pull request comment has run test as the start. It doesn't check if it equals to run test, it will only check if it starts with. so we can append further payload down the line there. Then it goes to step 1, 2, 3, and 4. The first step just checks out the current repo. Third step sets up the Python settings for it. And then the third step will create an environment variable called branch based on the user input directly passed in. And since we can control the input entirely because it starts with, we can pass in a command there to further exploit the chain and overwrite the run.py file to actually steal GitHub token. So when the workflow has overscoped permission to GitHub tokens, such as the read-write, which was by default, you could use that to steal the GitHub token and also write to the body there directly, and also steal secrets. And the second one is the user control runtime files. That's where the difference between pull request and pull request target makes a big difference, because for pull request, it is designed for malicious PRs or potential malicious PRs to run, so it doesn't have secrets access for the base repo. It also doesn't have access to GitHub token with the overscope permission of read-write. It only gets access as a read token. Versus if you go to pull request target, it's designed more for when an organization needs access to their secret to do some kind of a validation to their PR, whether it's pulling an integration test file from their AWS instance or any sort of things like that. So it will end up actually giving access to secrets. In this example, we have the pull request that the user created being cloned directly, and then a makefile running right after that, which will run the test script function within the makefile. Now, from a malicious point of view, you can update the makefile, create a PR, which will then end up running your makefile with the malicious code, stealing any secrets further down the steps. So for command execution, the impact is pretty standard. You can steal a GitHub token, even if it's not directly referenced in the workflow, because Actions Checkout, which is a third-party dependency that GitHub has, will automatically use GitHub token. It is default used. It will have it on the git config file, so you can steal that. And previously you used to have read-write access. However, when GitHub did change the permission, it hasn't changed the permission for past workflows. So before, whenever that change was made, which was earlier this year, if you had a workflow before that, such as created in 2020, that is still vulnerable, you will still have GitHub token that has read-write access to it, versus the new workflows will now only have read access. The second thing you can do, which is kind of more exciting, is stealing secrets on further steps down the line. So let's say if step 1 is vulnerable and step 3 is running a Python file passing in secrets.ssh, you can change the Python file there to actually exfiltrate the SSH file to your C2 servers. So that's, in general, RCEs, a basic vulnerability in GitHub Actions. The other one that we looked at more is the supply chain side of exploit. It has taken over a lot with dependency confusion. We have seen that with NPM, PyPI, and all of that. But GitHub Actions has its own way. For example, workflows are pretty extensive. You don't want to rewrite the codes that is already written. Classic example, again, Actions Checkout. You don't want to write your own checkout code. It's already written for you by GitHub. The other thing is there are a lot of maintainers who are writing their own Actions code. As a result of that, a lot of workflows tend to depend on those. But the question then changes is what happens if the maintainer changes their username? For example, in this case, here's a sample action, Tinder Rojan / sample action. And if you're using it in workflow A, and I change my username to Tinder Rojan new, what will actually happen on it? In most cases, GitHub will redirect that. So if you're using it directly in the workflow, you don't have to worry about the username changed, because GitHub will redirect when it's cloning it and pull the updated username and code from there. However, the issue exists when someone comes and claims that username. In some cases, GitHub tends to retire the namespace if it meets the criteria of having more than 100 clones or more than 200, 300 clones. There are some edge cases to it. But if it's not retired, a malicious attacker can come in, claim the username and the namespace, which is creating the malicious action at that point, and all the workflows that depend on it will start pulling the malicious code instead of the actual legit maintainer code. As a result of that, you may not even realize, but your workflow is now running the malicious code and giving access to all the secrets that are being pre-configured into that workflow. We looked into that a little bit more. So in 2022, when we were looking into GitHub Actions and building some scanners out of it, we were scanning about 10,000, 20,000 workflows at a time and pulling all third-party dependencies that we were noticing being used. In one case, we found a vulnerable example with this specific action, which was being used by about 316 plus workflows to basically create a JIP of their integration test. Without mentioning the vulnerable organization, one example we saw was they were building a integration suite, which will basically every time when the main branch has a PR merged, we'll run the integration test, get the results, and upload it to their S3 bucket with this action. The issue with that is we were able to fully take over the namespace. We tried running a sample workflow where we basically changed the code to just say, hello world, the username has been changed, with a tag that kind of referenced our internal research tag, which then we tried on our workflow and also the vulnerable company's workflow, and it ended up going through and actually running our command. What that could also have allowed us to get access there is the access key, secret key, and also their private SSH key and passphrase to it. In addition, we could have compromised the main branch, which could then be utilized to kick in a nightly build. And this nightly build will be updated into the maintainers or this organization's public S3 bucket where customers were pulling the updated software from. So it basically, in the end, gives an RCE not just onto the organization, but also all the customers that used it. Now, and this was not the only case. We found about 10, 15 different actions that were vulnerable to it, affecting more than 2,000, 3,000 workflows. So this is usually a pretty common case from what we have seen. A couple of ways that we saw organizations can secure it is one, pinning their workflow from when they are using third-party actions to the commit hash instead of the release tag or the version of the release or the branch. Mainly because when you use something like this, even though I can create a namespace of the action zip repo, I can't really create a GitHub action release with the commit hash on it. GitHub has additional checks which will check if the hash is like when you try to create a branch with the commit hash or when you try to create a release with the commit hash, it will block that and it will prevent it. We also, one thing we recommend is having a trusted list of maintainers and going through that to make sure no one else, you're giving your organization a list of users to trust and only use them. You can monitor those users and let them know when the username has changed. And also watch your build logs for any potential malicious activity. There are workflows or GitHub Actions built in that you can use, which will watch for any connections to external network and flag it to you if there are secrets being passed through. And then finally, the third vulnerability which we spent this year is looking at AWS OpenID Connect and GitHub Actions. Now at first, when you used GitHub Actions, the easiest way to connect with AWS was through the secret key and access key that you'll reference as secrets in your workflow. The problem with that is if you have a malicious attacker who has gained access to the access key secret key, now they have a long-term exposure, not just limited to that repo or to that time, so you could do more damage with it. However, now GitHub and AWS has released a new feature called OpenID Connect with GitHub Actions. So now you can get a short-term role where GitHub will send a JWT header to AWS and say, hey, this is the repo that wants access for this role. Is it allowed to do so? AWS will say, yep, this is good. Here's a short-term session, 3,600, 60 seconds, whatever you want to set the expiration for that. And it will also expire after the job is finished. As a result of that, even if an attacker gets access to the AWS credentials, they have a short-term access, and you can also monitor those for any kind of malicious use there. And also reduces the risk of any kind of API key disclosure there. The setup on that is primarily on the AWS side. So you'll create an identity provider that links to GitHub tokens or GitHub Actions tokens, and then you'll create an IAM role, which is supposed to check the audience and the subject header. The audience header is customizable to a lot of degree, even though it is by default the GitHub org repo name, versus if you use a GitHub action by AWS, like configure AWS credentials, it uses the client ID STS Amazon AWS. So it is mostly customizable. GitHub does have some checks on it that will give you authorizations error, but it's mostly there. Versus subject header is where primarily the access control lies, because you want to validate the proper access control, making sure only the org or the repo can access it. Now, in most cases, it's not customizable. There are some things you can add to it. You can add like your environment names for the GitHub Actions and whatnot, but it still has pre-configured tags to it, which makes it hard to fully customize or exploit it further. And by default, the format is basically a repo, the namespace, and the branch. So if you just want your organization's any repo within it to access, you can do repo :org name /* in the subject trust policy or your IAM role trust policy, and it will only give access to that. Now, from GitHub side, the setup is pretty standard. If you use the third-party action, you can just reference the IAM role. It will assume that. It will run the required activities that you want it to do based on the access it has, and then you can move forward from there. Versus now our theory was, okay, here's a lot of organizations using it. How could they misconfigure it? One of the things we looked at is, are there organizations not checking the subject header, since it's not really a requirement? The main requirement is having the audience or the audience header, but not subject header when you create the settings. AWS will flag it as a security issue if you try to create, but a lot of organizations don't tend to do it. So we started scanning again, a lot of workflows again, and the first organization we found vulnerable was AWS itself. So we looked at the repo, AWS docs, which is the SDK examples that AWS has, and what they were doing is building a new feature which will basically create images for each SDK example as a Docker in their ECR, and you can clone it, put it your access key and secret key, it will run it for you, and it will show you how to run AWS SDK. The problem was they were building this new workflow pretty recent, so it will basically use the IAM role to it, assume that, and then push it to their ECR. So we tried assuming the role, and it actually went through. At that point, we didn't even try messing it forward. We didn't know what other access it could have. So we reported to AWS and then went ahead and started scanning for more. As AWS was patching it, we started looking into the same repo, going through the commit history like you would look for secrets, and found that it had another role for a different AWS infrastructure, which pointed to an admin IAM role. Not really sure how admin it was, but we're also able to assume that role. And then after that, as we saw, initially our thought was, okay, one organization may be vulnerable or one simple workflow by a user. We didn't really know what the impact of that could be. So we started scanning again, going through every workflow we could find from source graph that had a IAM role attached to it in the ARN, like with the configure AWS credentials on it. Some of them still use IAM as a secret, so we couldn't really pull the IAM role, but for the ones that we could put, we started analyzing it. So we found about 3 different IAM roles for AWS, giving us access to their infra. We also found multiple Web3 companies to be vulnerable, which basically allowed us to change the prices for their crypto assets as it was coming back to the user, so messing with the prices there. And also to a government body's internal infra, really can't mention the government body, but they were also vulnerable. A lot of open source stuff going on there. And a lot of educational institutions, especially the research side of a lot of institutions, they were building it directly via CLI, not changing a lot of things, just going and setting it up, so that made them more vulnerable there. However, we did report all of these to the organization, so everyone passed it as we were reporting it. The only thing is there are still more vulnerable organizations. Just as of last week, I read a blog from another company who used our research, went ahead and scanned more, and they found more organizations to be vulnerable. So this is not just a one-stop case. There's a lot of more existing cases. If you do want to secure it, there are a couple of ways. So our infrastructure security team worked with SteamPipe. So if you use SteamPipe, there is a pre-configured scanner that can be used, and it will basically flag any kind of vulnerable trust policy that use GitHub Actions there. You can also use a open source tool we have released. So we have released 2 GitHub Action related tool. One is just a regular Python that will parse a workflow and tell you any vulnerabilities and also look at third-party dependencies. This one is more of a GitHub Action that you can reference, scan another organization with it, and it will flag any vulnerabilities on that org. So if you have multiple org within your enterprise in GitHub, you can use org A to scan org B, flag for any vulnerabilities. It will export a JSON file with the exact repo that's vulnerable and the ARN, so you will know which workflow to look at. So this is more of a black box approach to this as well. Now, securing it is pretty standard when we look at GHA in general, not just for OIDC. The first one is always sanitize user inputs. So to kind of wrap it up there, you never want to trust user commands there, whether it's user control files, user provided comments, bodies, whatever there. If you're looking at supply chains, always make sure you're monitoring the users there. You could create settings in GitHub where you can only allow third-party dependencies from certain usernames or certain trusted ones, such as Actions is the only one you can allow as well, or you can create a list of usernames to monitor. And then finally, secure OIDC configurations. It's pretty straightforward in securing it, but it's also really easy to make it vulnerable. That said, that was pretty much the wrap up. Here's our GitHub. You can go to Tendersec. You'll see the 2 open source tools we have. We have more to come. If you want to read more in detail about the OIDC one, we did post a blog about a month ago, so you will find it in our Medium. And then if you want to follow our Twitter account, we have posts of any other research we'll publish there. Thank you.
Thank you, Rojan. All right, questions for Rojan?
As regards the workflows where there's basically the issue with workflows where the name has been changed and the name is open, how effective would it be as an organization to fork the repository for workflows that you're using and only update it once you've gone through and checked changes.
That's a really good way to do. So I've seen some organizations do that where they'll fork it instead of relying on the maintainer. The only risk then is if there's a security issue on the action, you'll just have to update it as you go. But that's a really great way to do it as well.
Other questions? All right, well, thank you, Rojan. So we have a few minutes before our next session, and just as a quick reminder, please go into Slack. If you plan to participate in the Incident Response Game Day Challenge, do a thumbs up so we know. And then also, please visit our sponsors. Thank you. Did you have a question?